So we can compare box and whiskers, we can see how they're displayed. Athlete A, would you say they're symmetric or skewed? Symmetric, so they're pretty even on both sides. They're not too far away from their middle. What about athlete B? So he had one, I shouldn't say one, but some skewed a little bit that way, just a little bit, maybe. Not a big skew, not bad. Okay, so we're gonna look at box and whiskers again and kind of add a little more details to it as we look at a few today and see how we can find the information quicker. We've been talking about what measures of center are best, our mean, median, and mode, and it pretty much depends on an outlier. Of course, mode we just use when we're talking about non-numerical data. So tell them you gotta take out your earbuds, please. Anybody with earbuds needs to have them out, or they'll have to take them. And so that's the measure of center. Mean and median, it depends on outliers. If there is an outlier, is the mean or the median the best measure of center? Median. So when there's not, the mean is going to give us the average. So we're looking at that today, but we're also going to look at what measure of dispersion is best. Range is a dispersion. We know standard deviation is a dispersion. And yesterday we found the 5-point summary, which lays out a box and whisker. So it's a measure of dispersion. It's going to show us how spread apart our data is. So let's talk about the measures of dispersion for just a minute. Come down here, will you box that? There's two specific measures of dispersion we need to understand more about. The first one we've been working with, let's talk about the standard deviation. We worked with that a little bit. We found it on Desmos. We used it, deviation. We used it to make our normal curves. You add the standard deviations to the right of the mean and you subtract them to the left. And so we used it when the curve was normal, which was symmetric. So if it's symmetric, what measure of center did we always use when we're symmetric? When there's no outliers. The mean, yeah, the mean. So standard deviation, we use it, you use it when the graph is symmetric. The standard deviation helps us when our graph is symmetric, and that means probably there's no outliers. There's no outliers. So the center we would also use would be the mean. So anytime your graph is symmetric, the mean is going to best represent its center because there's probably not outliers. And also the standard deviation is going to be the best measure of dispersion because it works on symmetric layouts. So they all go together. Mean goes with standard deviation. I spell it right, it was funny. Anyway, standard deviation. The other measure of dispersion we're going to talk about today, number 2, is the 5-point summary. It's an actual measure of dispersion because it lets us display a box and whisker. And it will show if it's short, like the first one, if it's symmetric, if it's skewed, if it's long. It tells us all that. So it is a measure of dispersion. So that will be used when we are dealing with, we work with 3 medians. We work with 3 medians on the 5-point summary. And so we want to use the 5-point summary when the graph is skewed. Because when we're skewed, we use the median as our center, and the 5-point summary does use 3 medians. We've got the actual median, quartile 3, and quartile 1. So when our graph is skewed, we know there's probably an outlier, so we would use the median as the best measure of center, and also the 5-point summary would be the best measure of dispersion. So let me show you how we're going to use this today. Always remember when we're symmetric, we use the mean and the standard deviation as the dispersion. If we're skewed, we use the median and the 5-point summary. The 5-point summary has 3 medians in it. So you're going to be graphing some box and whiskers today, and then you're going to be asked 3 questions. You're going to be asked first, is it symmetric or skewed? This first one, what do you think? It is symmetric, so let's put symmetric there. And then it's going to ask you what measure of center, I would put this in your notes so you remember why you chose this. What measure of center would we use? If we're symmetric, there's probably not outliers. So what measure of center do we use when we're symmetric? The mean. And then I just told you the best measure of dispersion when you're symmetric is going to be the standard deviation. And I'll let you abbreviate that to this, standard deviation. So anytime you're symmetric, whether it's a box and whisker, a histogram, the normal curve, anything like that, you'll use the mean as the best measure of center and the standard deviation as the best measure of dispersion, how it's laid out. This next one, is it symmetric or skewed? Skewed. Skewed, and in particular, which way? Right or left? Where's the long whisker? To the right. Yeah, so I'm going to have you say specifically which way it's skewed. Then I will ask you for the measure of center. If you're skewed, you probably have an outlier. So what measure of center do we need to use? A median on that one. And then we just learned that the measure of dispersion to use with that is going to be the 5-point summary. Because your 5-point summary does have 3 medians in it. And it will show you that display, and it will show you where most of the data actually is, not the long whisker. Okay, so those are what we're going to be doing. So we've been using box and whisker. We've seen bar graphs, but we can also get the same information from a dot plot. We haven't had to graph any this year, but these are 3 variations of dot plots. You can use actual dots. This one use squares. This one use stars. It doesn't matter. But it does show you the display, how it's laid out. The first one, do this with me. If you were to outline it, would you say that it's symmetric or skewed? Yeah, pretty darn symmetric. So if it is symmetric, what measure of center would best represent this data? The mean would, yep, measure of center, and which measure of dispersion? Standard deviation. Yeah, when we say center, that's mean, median, mode. When we say dispersion, that's standard deviation and 5-point summary. Okay, this guy over here, outline it. Would you say it's symmetric or skewed? Skewed which way? Skewed left. So if it is skewed, there's probably an outlier. So do you use the mean or the median as the center? The median. And would you use standard deviation or 5-point summary? Yeah. Anytime you're doing the median, remember the 5-point summary has 3 medians. So they always go together. They always go together. 5-point summary. In the last dot plot, when you outline it, is it showing a symmetric or skewed display? Skewed which way? To the right. So skewed, you probably have an outlier. What's the measure of center? Median, what's the measure of dispersion? 5-point summary. And so we got to keep all those funny words straight today. And on the assignment, it gives you, it's a worksheet today, it tells you, it reminds you at the top what each of those are. It will say measure of center, mean, median, or mode. Measure of dispersion, standard deviation, or 5-point summary. The display, skewed or symmetric. So it's going to remind you what's what. Okay, so we can do that with a dot plot. Now, a dot plot we can also get some cool information from. This one is showing the number of televisions owned by each family on a city block. Would you say that's a symmetric or skewed? A little bit skewed, which way? Right, so there's not many that have 6, 7, and 8 TVs. So what it's telling us is that one family had no TVs. 3 families had 1. So the stars are how many families answered for each value. 2, 5 families had 2 TVs, 4 families had 3, and so on. So could we figure out how many families live on the block? What could we do? Count them. Count what? The stars. That's telling you how many families were asked. Count them up. Tell me how many families live on the city block. 21. Everybody got 21? It is 21. How many families have more than 3 televisions? More than 3. 8. What are we adding up? Everything more than 3. 4, 5, 6, 7, and 8. There's 8 families that have more than 3. How many families have more than 1 but less than 4 TVs? Which ones are we adding up there? Yeah, the 2s and 3s. Right there, there's 9 of them. So we can get specific information, we can get general information, we can say most of the data is over here where the 2s and 3s are. We can say lots of different things just by looking at the display of our data. So we can get that from a dot plot. We haven't worked tons with it today, but we can get that same kind of information from it because it lays out symmetric or skewed. Now, we've been working Box and Whisker. We've had to find the 5-point summary by hand. We had to list them, least to greatest, find the middle, big, small, middle, middle. Today, we're going to let our handy dandy Desmos calculator find those 5 things for us. So take out your Chromebook. We know how to use it for standard deviation. I'm going to show you now how to use it to find the 5-point summary. The minimum, quartile 1, median, quartile 2, the max. So grab your Chromebook. We get it out. Grab that Chromebook. Go into Desmos.com. Keep your notes out because the steps are right in the notes. And I want you to follow along because I'm going to pull up a Desmos and you won't see them up here. So follow along on your notes. Get that pulled up. Should look like this. Pull it on up. Desmos.com. Choose the graphing calculator. And just like the standard deviation, we need to give the calculator the data. We're going to do it a little bit differently. We put it on a table before, which is a great option, but I'm going to show you another way. You can give it a list of numbers. So to give it the list, you need to put a capital L equals in that first line. Capital L equals, and then you need the hard left bracket. So you have to shift left bracket. Oh, yeah. Shift left bracket. So L equals, and then we have to put them in a hard bracket. And then we're going to use the data on the notes, right there, the 2, 2, 3, 10, and so on, to type in. You do have to put a comma in between each of them, so it knows that they're individual values. So 2, comma, 2, comma. Get them all in. Be careful entering. Even though it does all the work for us, we do have to put our numbers in correctly to get the right answer. So comma 9, 7, 1, comma 4. And you'll want to be sure to have all the data. And it used to tell us over here how many are in your list. It used to say the list has 10 elements. Or, I don't know why it doesn't say that anymore. You can see that on your notes. It used to say L equals 10 elements. I don't know, but make sure you have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make sure they're all in there. Any questions so far on entering the list of numbers? So this is another way to enter your data. Make a capital L. Here's my list. Now again, you have to click down on line 2. Go out of line 1. That's just where we're putting our data. Now in line 2, we're going to tell the calculator to find the 5-point summary. So again, go to your little keyboard over here on the left, come to functions, scroll down to statistics. There's a whole bunch. We want the quartiles and the min and the max, but to get them all at the same time, we're going to hit this stats button. Bottom right corner. Bottom right corner, hit stats, and then we got to tell it what to take the statistics of, and we want it our list. So put in your capital L that we just created, and lo and behold, look what it gives you. The whole 5-point summary, just like that. You don't have to count in, you don't have to make sure you've got them in the right place. There it is. So in this blank space, will you write those 5 things in? Write in min is 1, quartile 1 is 2, median is 5. And then we're going to graph it on the number line that's in the box next to the blank box. You can graph it right there in your notes. So as long as you get the data entered in correctly, you are going to be set with that 5-point summary in a blink of an eye. You just have to be sure to put in the data right, so it gives you the right amount. Okay, so once you've written it down in the blank space, use it to create the box and whisker on the number line that's in your notes in that bottom left-hand box. Let's put a point for the minimum above 1. Our quartile 1 is on 2. Median is at 5. Quartile 3 is on 8. And maximum on 10. Remember, you box around quartile 1 to quartile 3. Put a line through the median to make it stand out. Whisker to the min and the max. So that's how you'll be creating your box and whisker today. Any questions on that much? Okay, then you're going to be asked those 3 questions. It's going to ask you, what is the display? That is asking you, is it symmetric or skewed? Would you say this one is symmetric or skewed? Yeah, it's pretty even on both sides. To be skewed, you've got to have a pretty long difference in a whisker. So let's put symmetric by this. And then it's going to ask you, okay, if it's symmetric, what measure of center? Mean or median or mode? Everybody agree with Shelby? Because she's right. If you're symmetric, that probably means there's not an outlier. So the mean. What measure of dispersion, standard deviation or 5-point summary, goes with symmetric? Standard deviation, yeah, because it involves the mean. We use the mean on standard deviation. Yes, so that's how you'll answer today. You'll be getting your 5-point summary. It has a spot on the worksheet for you to list them, and then you'll graph it and answer those 3 things. That's what you'll be doing for most of the worksheet. Any questions on that much? Okay, let's get started then on the worksheet. I want to do a couple of them with you. So when you get it, put your first and last name on here. Then we're going to work through 2 parts of it together. Because I always get questions about one particular thing, so we might as well talk about it now. And then Dax, can you grab your spoon while you're doing that? First and last name is the 28th today, and I forgot to talk to you about that while I'm thinking about it. Guys, end of quarter, I sent an email home, hopefully you saw it. End of quarter due date for me is the 12th, and with it coming towards the end of the year, we're kind of getting low on some supplies. So if you can help me out, I'll be willing to help you out. I can offer you 1 assignment forgiveness for a school supply. So if you could bring in a Kleenex box, pencils, at least like 8 to 10, so paper, whiteboard markers, paper towels, Clorox wipes, those kind of things. If you can bring that in for 1, I can excuse 1 of your 3rd quarters. Or if you're good on 3rd quarter, we can save it for 4th quarter and use it then. If you ever get in a bind and can't finish an assignment in 4th quarter, we can apply it to that. So that's your option to help you a little bit and to help me a little bit. Any questions on that before we move on? Okay, so on your assignment, go to number 4. We're going to look at number 4 together real quick, and then 1 more after that. Okay, so number 4. So go to your Desmos. We've got, somebody asked some students how many pets they own. So start entering this data. You already have your L equals in the bracket. You should, hopefully. If you need to type it back in, type it back in. And put in, and you've got long lists today. So you got to be careful typing them in. Make sure you get them all in. There are 15 in this list, so make sure you've got all 15 of them ending at 1. Type them in. Get them all in there. You already asked it to find the stats on line 2. Hopefully you still have that there. And it will just update to your new data. You know, notice on the assignment, you guys, the order is not the same as we normally have it. So you gotta make sure you're putting the values in the right spot. What did it tell you the median was? What is it? The median? Yeah. Yeah, not 13. There's not even a 13 in the list. Yeah, don't put 15. That's just the number of. Yeah. Did everybody else get 2? Hopefully. Okay. What's quartile 1? 1. What's quartile 3? 4. How about the highest number and our lowest? 0. Okay. So if you didn't get those, try it again. Put the numbers in. Then you'll graph it. You'll put a point above 2, a point above 1, and all of them. 9 and 0 locks out the quartiles with a line through the median. Whisker. So put that on your number 4. Now the distribution. If you forgot what that means, just look back at the top. It says distribution. It's either skewed or symmetric. So is this one skewed or symmetric? It is skewed. In which way? To the right. So I want you to be specific on the direction of the skew. That means most of the data is on the left side. Best measure of center. If we look up here, we're talking about mean, median, and mode. When you're skewed, what's the best measure of center? Which one is it? That's the next one. Measure of center is the median. Yeah, the dispersion, that's either standard deviation or 5-point summary. And yes, when you're skewed, you want to use the 5-point summary because it has 3 medians in it. We found 3 medians, so they go together. Any questions on how to do those kind? That's 1 through 6. Okay, now I know you're in the group, but to flip it over to the back, you're going to want to do this one with me. Go to the back. Most of it's pretty straightforward. There's a couple questions here that I get a ton of questions on, so we're just going to talk about it right now. So this box and whisker shows the heights of 40 randomly chosen adults. So there it is. What is the range of the heights? How do you find a range? Yeah, highest subtract smallest. What is our box and whisker telling us the highest is? 79 minus, what does it tell us our lowest is? 58. So it does tell us highest and lowest, so we can find the range. What is 79 minus 58? So that's the range. That's a pretty big range. That's a big box and whisker. It's pretty long. What's the range of the middle 50%? On a box and whisker, what shows us the middle 50%? The box does. So we do the range of the box. What's the high end? What's the quartile 3? 72 minus what's our low end? 65. So the middle 50% range, the IQR basically interquartile range, is how long? Okay, how many adults are exactly 68 inches tall? Does a box and whisker tell you every data value? No, it only tells us these 5 things. But what is 68 on this graph? The median. Let's think about that for 1 minute. If there's 40 people on our list, do you have 1 number in the middle or 2?
2.
You for sure have 2. So they could both be 68s, right? And that would be the median. Or they could be 67 and 69 and the middle is 68. Do we have any idea exactly how many adults are 68 just knowing the median is 68? No. So we would have to say this is not possible. It's not possible to do exactly because 68 is just the median. We don't know exactly how many. There could be 2, but there could be even more. We don't know. There could be none that are 68. Who knows? Who knows? We don't know. With a box and whisker, we don't know. All we know that that's the median. That's the middle. So that helps us on the next question. What percent of the adults are 68 inches or shorter? What percent would be 68 inches or shorter? Colin says 50. Do you guys agree? If 68 is the median, is that right in the middle? Yeah, so shorter than that, there's got to be 50% shorter. and there's 50% taller than the median, the person in the middle. What's the height of the tallest adult? Yep, that would be our maximum, 79 inches, foot inches. How many of the surveyed adults are at least 58 inches tall? Jack says all of them. You guys agree? Because what's 58? The shortest. So everybody at least means greater than or equal to. So yeah, all, or 40. We know there's 40 people, or 100%. How many? 40 of them, all of them, are at least greater than or equal to 58. Describe the distribution. Guys, is this skewed or symmetric? Yeah, it's pretty symmetric. And then it wants us to explain what it means in this situation. So this box and whisker is talking about what? What's it telling us about? The heights. If we're symmetric, so what does it even mean to be symmetric? Even on both sides, yeah? So what would be true about the heights of people compared to that median? Shorter and taller, what would be true? Same amount of people are shorter and same amount are taller. Yeah, if you're symmetric, you're pretty mirroring on both sides. So you can just say something as simple as there's an even amount of shorter and taller people because it's symmetric. So we're going to be pretty even on both sides of that median. There should be a fairly even amount of shorter people and a fairly even amount of taller people because it's going to be symmetric. Okay, the rest of the time is yours to finish. The other question on the back should be fairly straightforward. We walked through one similar to that on the notes. And then you've got your Desmos. So go ahead and keep working.